Welcome again, everyone, to G Squared Academy, where excellence is epitomized. I know it's been a while, guys, that I've not posted an educational video, so to speak. But I actually teach. So I have been quite busy teaching and learning from students. And that's how I make my videos. The issues that I have or issues that students have, I try to do videos to explain those things so that it will better enable them to do what they're supposed to be doing. And as you can see on the screen there today, I'm going to do another helpful video. This is not just for chemistry students, but once you're doing sciences generally, these are things that you can pay attention to. How to write up a lab report. And we try to follow the scientific method in science, clearly, because it's science, we're trying to follow the scientific method. But one of the lab report is one of those things that students are told in their year 7 or first form, grade 7, whatever it is called, middle school, I don't know, that hey, this is something that you're going to learn when you get to fourth form or grade 10. And then when they get to grade 10, the teacher says this is something that you would have learned in grade 7 or 8 or even 9. But then students never actually learn these things and they have to pick it up along the way. And so a lot of mistakes are made, and instead of maximizing on marks, you don't maximize on marks. Anyway, I've been doing too much talking. Let's get into it. So, um, I personally have some preferences in terms of the order of the lab, and there are some well, I would say scientifically accepted ways of writing up the lab. So that you have to do certain things first. For example, you must have observations before you can discuss your observations and then draw conclusions. You can't conclude and then you're gonna put your observations and your discussion. So those things, you must have them in that particular order because you're thinking of it like a logical sequence. Anyway, we're going to get in. So the first thing you want to have in your lab is your lab number. It might seem quite trivial, but you need to have a lab number. It's good. Why? Because it makes your lab easy to find and it makes your book look more organized. So you want to have your lab number. It's like a table of contents sort of issue there. Okay, so no big deal. The date, some people are thinking, you don't have to have a date in a lab, but I just disagree. I think your lab should be dated. Any work that you do should be dated because the date plays an important role in science. When things are discovered, it's quite critical. You can get a Nobel Prize based on the fact that you have the date and it came one day before somebody else did their studies, and you published your work one day before. So the date, I think, is quite critical. So I think you should have a date in your lab. Your lab number, then your date. All right, then your topic. What am I looking at? What is the topic that we're dealing with? So this is really for syllabus coverage. Um, so there are certain topics that you must do in your exam for your SBAs. And so you want to show the examiner that you have covered these topics that you have to do. And so therefore you put your topic for mostly for syllabus coverage. Good thing to have as well. Then the next thing is your aim. You need to have your aim in your lab. And of course, your aim begins with 2. And this is what you're trying to find out in your lab. You have to have an aim. You can't get around this. You must have an aim if you are writing up a lab experiment. There must be something you're trying to find out. Okay, and as I said, it always begins with 2. An example, to investigate the effect of concentration on the rate of reaction between magnesium ribbon and hydrochloric acid. Right? So you have to have an aim when you are doing your labs. Remember now, this purpose of this video is just to help those students who are not sure what they should have in their lab when they're writing up their report so that they can maximize their marks. And these are the things that you need to have. So after your aim, you have your title. And of course, for you to get your title, really, all you're going to be doing, it's really a mimic of the aim. And as I said, I just gave you an aim. So in this case, your aim was to investigate the effect of concentration and the rate of reaction between magnesium ribbon and hydrochloric acid. Then all we do for your title is we're going to be removing the to. So we get rid of the to, and then we're going to change the investigate to present continuous tense. So it becomes investigating. And so your title would be investigating the effect of concentration on the rate of reaction. So it's pretty much the same thing. It's just that you're changing a few things. All right. So when you're writing up your lab, that's exactly what you're supposed to be doing. Okay. I mean, there are many ways to skin a cat. Not that we want to skin a cat, but metaphorically speaking, um, your title can also be written in other ways. But this is the way that I think is quite easy, and it encapsulates what you're doing in your lab for real. All right. So after your title, then the skill. Which skill are we trying to develop in this lab? Now, it is imperative that students learn the skills and develop the skills that they're trying to develop in their scientific study, right? And oftentimes students really don't know the skills. It's sad, really. So in science, we're really trying to develop some skills, and there are 5 CSEC level that you want to develop. Drawing really, drawing really is for biology, and then you have your ORR, observation, recording, and reporting, right? So there are specific things that you do when you're drawing. So there are specific things that your examiner looking for. I can do a video for that if you want. So you can just let me know, write a comment if you want me to do a drawing video for you, or a skill video to highlight the things that your examiner looks for. Um, then now you have your observation, recording, and reporting. As the name says, you observe, you record it, you report it. And there are specific things that your examiner looks for as well when you're doing that, in terms of tense, structure, etc., etc. Then your analysis and interpretation. Really, this is mostly about doing calculations, um, discussing data, explaining data, etc., etc. Really, that's what your analysis and interpretation is all about. In your manipulation and measurement, can you use laboratory apparatus and materials? Can you titrate? Can you measure something using a measuring cylinder? Can you measure something using a thermometer properly? Because of course people will do things like that, but they're not doing it properly. And there is a way how to do these things properly so that we can get accurate results, right? And then you have your planning and designing. If you have any questions about planning and designing, which is one of the more difficult ones, you can refer to my videos how to write up a planning and designing lab for CSEC and CAPE. I'm just going to put the link in the video right at the top there right now, so you can look for that video and watch it. It's an okay video, and I think it may help you. So so these are the skills that you may be developing. Chances are you might be doing 2 of them, but usually not more than 2. If you're doing drawing, it's really just drawing, and if you're doing PD, it's only PD. But you can have a mixture for ORR, AI, and M&M, but usually just 2 of those are being developed. Right? So that's your skill. You should have this in your lab. Next thing now, it's your apparatus and materials. So these are, of course, the things that you're going to need to accomplish the things you need to accomplish your objective or objectives. Just to say that your apparatus are things that you can reuse. So you could reuse a beaker, thermometer, a burette, pipette filler, etc., etc. But then your materials are chemicals really that you cannot reuse, like water and your hydrochloric acid, your magnesium, your bond. So you need to have these things in your lab when you're writing it up. One of the things, and I pause here, one of the things that you should remember now is that your lab really is a report of what you have done or what was done. So when somebody reads it, they should be able to take what you have reported and carry it out for themselves without even asking you a question and get back the same results. So therefore, it has to be on point. It has to be solid information that you are producing in your lab. So you have to record your apparatus and materials so that Jim Brown can go and do it for himself. All right. So after that, now your background. Some labs may have a background or may need a background. Not necessarily all labs will need a background, but if your lab needs a background, what really is your background? Um, it it's, as I said, it's not necessarily for our labs. It's just a little theory a little information about the theory of the lab. Of course, in science, we try to match the theory to the lab. So you do the theory and then you see it in practice so that you can actually see some evidence of the theory. That's the whole idea of the lab. And so in your background, you're just going to give a little bit of information about the theory of the lab. So here's an example. If you're doing a lab about photosynthesis, then your background, it would be good if you define photosynthesis, then you could give an equation for photosynthesis, conditions necessary for photosynthesis, and things which affect the rate of photosynthesis. You know, that would be a good background. And you want to write this in paragraph format in the form of a story. So the information needs to be flowing. So you move from one point to the next point smoothly. All right. So that's your background information. Next, we have your method. Of course, important thing. So these are the steps that you're gonna to take to achieve your objective, right? Importantly, you must write it in point form. Why must I write my method in point form, you may ask? But here's the situation. We are scientists, and so therefore, if we write it in point form, it is much easier for us to track any errors that we make. Okay, it's much easier for us to track any errors that we make. So let's say you're doing a lab and an error was made somewhere. You look at step one. Okay, I carried out step one. Good. Step two, I did step two. Yes, yes, very good. And then you look at step three. Whoa, I didn't do step three properly. You see what I'm saying? So therefore, you can clearly see that you followed the steps and you can see where you made mistakes. And so you can correct that. When you write it in a paragraph format, step one is not distinguished from step two or step three or step four. So you're then going to have to decipher what step one, step two is. And you might get that a little bit mixed up, and you don't want that. So therefore, it's best you write it in point form. All right. Now, except for your PD lab, it should be written in past tense. Generally, it's something you have done, so you should write it in past tense. Your PD labs should be written in present continuous. All right. So you do that. And of course, I said this already. Why? Easier to pick up errors. Okay. Then after you have carried out your method, you will then have your results or your observations. Results are observations. And of course, this is just what you observed in your experiment. It could be that you record your observations like a paragraph. I observed that the leaf turned blue black, or I observed bubbles being formed, or something like that. And of course, you do not write I in your observation. So you'd say it was observed. Sorry, I should not have said I. So you'd say it was observed that bubbles were formed, or the leaf became blue black, or the ethanol turned green. This is the sort of thing that you'd write down. So this is your result. Or you may record your titration results in your table. That's also your results or your observations, right? So that's really your results and observations. And usually, if data is there, if there's enough data or a lot of data, you're advised to use a table, because a table really helps to simplify information. And so therefore, writing the results in a table is a very good idea. All right. So just something to point out, that the purpose of any lab is to get results. No matter what level you're at, when you go to a lab, you're going there to get results, really. And in trying to get results, you're going to develop the skills for you to get results. And when you get results, you're going to try to improve those results to get better results, right? And so that's how you're going to develop the skills that we're talking about here. Okay, then your discussion or your treatment of results. What do I do with my data when I get it? Okay, I have observed something. I'm now going to explain what I've observed. Okay, so you're analyzing your results. Or I may plot a graph. I could plot a graph to explain my results, and then from the graph I answer questions. Or I could do some calculations. Okay, so you may have to draw a graph and then answer questions from the graph. You may do calculations, and you may have to just explain your results. Usually, it's one of these three things. You either have to draw a graph, explain your results, or do some calculations. Almost always it's one of those things, or a mixture of those things. right? So that's usually what your examiner is expecting you to do. And of course, that's dependent on the data that you have and the information, observations that you're working with. All right. So after your discussion now, so you have done your method, you have carried out your lab, sorry, you have an aim, you have your apparatus which you use to carry out the lab. You have your method now, the steps you took to carry out the lab. You observed some things. You have now discussed those things. Then now, what can I conclude from all of this lab? What can I conclude? And students always have an issue with writing a conclusion. Your conclusion really is an answer to your aim. Okay? Your conclusion is an answer to your aim. So before you ask the teacher, before you ask the examiner, what is the conclusion for the lab? The first question I would ask my students is, what is the aim for the lab? What's the aim of this lab? All right. So, and just a few things before I even go back there. Do not restate your results in your conclusion. Okay. Do not discuss the results. You have a discussion for that. Restating your results is basically rewriting your observation. Discussing your results is really is a discussion. You simply answer the aim. And now we're using an example. If your aim was to investigate the effect of concentration on the rate of reaction between that, what did you find out? What was the effect of concentration on the rate? So your conclusion could be, as concentration increases, the rate of reaction between magnesium and the ribbon and the hydrochloric acid increases. You have answered the aim. This is the effect. The effect of concentration is that it increases the rate, right? So therefore, simply answer your aim. Now you notice with this conclusion that it's not a long epistle. It's one sentence. Remember, it's quality versus quantity, and we'll always choose quality over quantity. All right. Don't write a lot of things and expect to get the marks when it's not quality work that you have. All right. So therefore, write something, answer your aim. What is the aim of the lab? To investigate the effect. What was the effect? As concentration increases, the rate of reaction increases. So therefore, concentration has a positive effect on the rate of reaction. All right. And that's pretty much the parts of your lab write-up right there. That's it. However, however, there are some other aspects of the lab that your teacher may want personally, or they may say that you should have those things in the lab. You know, things like your limitations, sources of error, precautions, and stuff like that. Those your teacher may ask for those things. And if it is that you're having difficulty in understanding your limitations, precautions, sources of error, and your assumptions, you can also refer to my video again on how to write up a planning and designing lab, which explains those things, I think, okay enough for you to understand. Right, so there you have it, guys. I'm hoping you find this helpful. You know, I just really want to help people to understand the science and how to do things so that they can improve themselves, feel more confident. You know, I hope you find this helpful while you're at home in quarantine, while you're not quarantine necessarily, while you're at home in lockdowns and such, and you have to write up your labs still. You know, I hope you find this helpful, that you're able to now see the steps or the parts of your lab that you should have, and that you can do them properly. Please um share this video with your friends, let them see what's going on so that it may help them as well, you know. And like the comment, if there's something that you want me to, you know, explain further, just comment on it, let me know what's going on. You know, I'm here to just help you to improve really in your sciences. Subscribe to my channel, G Squared Academy, you know, where excellence is epitomized. All the best in writing up your labs, and I'll see you next time. When you finish, you get your stuff, baby. Thanks.